Alright, in this video we're going to look at some questions using the concepts from units 3, 4, and 6. Okay, so first question here is they give you a function which represents the number of answering machines sold, where X is the number of years since 1980 in millions of years. Okay, so first thing I would do is let's plug this into our calculator. They want to know how, use this function to find the number of answering machines since sold in 1990. So you actually have a couple choices here. How many years have gone by from 1980 to 1990? Well, looks like that would be 10 years. Okay, so let's do this a couple of different ways. Let's first plug it into y equals. We've got negative 0.010789 x to the power of 3 plus 0.2226 x squared plus 0.311 x minus 0.75. Okay, so if we hit graph, here's our graph. Okay, and we want to know where is the use the function to find the number of answering machines sold in 1990. Well, if we go to our table of values, okay, based off of this graph, it says X is the number of years since 1980. So this would be 1 year after, so that would be 81, 82, 83, 84, 85, 86. So if we go down, 87, 88, 89, 90. So that's 13.8. So since they're answering machines, let's round that to a whole number. So let's call that approximately 14 answering machines. Okay. Now, the other way you could have done this, you could have just filled in 10 because that's the number of years. X equals 10 years since 1980. Okay, so you could have plugged this in. You could have done negative 0.010789 parentheses 10 to the power of 3 plus 0.2226 open parentheses 10 close parentheses squared plus 0.311 times 10 minus 0.75, hit enter, and there's the 13.831, which is the same thing we had when we looked at the table. Okay, so either way, on 73 here, which graph is the graph of the following function? So again, we could plug this right in our calculator, or we could say, hey, let's find our x-intercepts. Well, x-intercepts were y is equal to 0. So in this case, x would have to equal 3. Here, x would equal 2. And here, x would equal negative 1. Because remember, if you bring the term to the other side, when they're set equal to 0, you do the opposite sign. So we're looking for x equals 3, 2, and negative 1. So we have 2 positive, 1 negative. Well, here's 2 positive, 1 negative. This is 2 negatives, so it can't be B. This is 2 negatives, can't be D. This has 2 positives, so which of these? We need a negative 1. These are both negative 1s. Then we're looking for a 2 and a 3. Looks like this is a 2, that's a 3. This looks like this is 1.5 and 3.5. So answer is C. Okay. Then